Lesson 9.1, we're working with the distance and midpoint formulas. So the first thing I'd like you to do is to pause the video and to write the distance formula and the midpoint formula in your notes. A couple of things I find helpful is to jot down kind of like the template, just leave the x and y values out so that it helps me keep my signs straight. And the other thing you should do is label your group 1, x1, y1, and then x2, y2. So it's just group 1 and group 2. And we could flip it. We could call this group 1 if we wanted, and we'd still get the same answer. All right, so we're going to begin and we're going to sub in our x values. So it says -3 minus -5, 2 minus 1. So here we said add the opposite, so it's really 2 squared plus 1 squared, so it actually is equal to the square root of 5. And now I'm going to show you what it would look like if we switched our groupings. All right, so now I said this is group 2, this is group 1, so down here I put the -5, add the opposite, it became -2, and then add the opposite is a -1. -2 times -2, it's in parentheses, becomes the 4. -1 and -1 is 1, and it would simplify to the square root of 5. Our midpoint formula simply says to add the x's and divide by 2, and then add the y's and divide that by 2. So we have -2 plus 4 divided by 2, and then 3 plus -2 divided by 2. That simplifies to 2 over 2, which is 1, and 3 minus 2 is 1. So our midpoint is 1 comma half. So if you look at our graph here, if I went over 1 and up half, that's right there. So that's the midpoint of those two ordered pairs. In this example, you're asked to write the equation for the perpendicular bisector of the given line, or line segment, sorry. So we know that perpendicular means that it's going to be 90 degrees, and it's bisecting, so it's going to cut this little segment here in half. Some formulas you're going to need: a reminder of the slope formula and the point slope formula. So you should need to pause the video and put those in your notes. The first step is to determine the midpoint, or the halfway point. So I already solved that, and I found out that it's the ordered pair 1 comma 5. Our second step is going to find the slope of our given line. So we're going to be using this formula, the difference between the y's over the difference between the x's. All right, so for our slope, we said 6 minus the 4, 5 minus the -3, and it came out to 1/4. It's important to find the slope of the original line because we know that a line that's perpendicular will have a slope equal to the opposite reciprocal. So we really have a slope of -4 over 1 or -4. So our third step was determining the opposite reciprocal of the slope from step 2, and step 4 says to use the point slope formula. So we know one point on the line that's the perpendicular bisector, and that point is the 1 comma 5. So we put in the y value, then in front of the parentheses, that's the slope, and the slope we decided was -4, and then it's x minus 1. And then now we're just going to simplify that. So I distributed the -4, and then here I added 5 to both sides. So our final answer for the equation for the perpendicular bisector is going to be y equals -4x plus 9. And we have just one more example. In this example, we're asked to determine if triangle DEF is scalene, isosceles, or equilateral. And remember that scalene has all sides that are different lengths. Isosceles will have 2 sides that are the same, and equilateral will have 3 sides that will be the same. We're going to have to apply our distance formula to find the distance between D and E, then E and F, and then F and D to determine if we have all different sides or some sides that are the same. So when I input the values for point D and point E, I got the square root of 29 to be the distance. So if it's horizontal or vertical, we can count, but whenever we have a diagonal, we have to use the distance formula. So now let's do E to F. So for E to F, we ended up getting 16 plus 9, so it's the square root of 25, and that simplifies to 5. One last side, we're going to go ahead and do F to D. Finally, for our last segment, we had 1 plus 25, so it came out to the square root of 26. So we have 3 sides that are different lengths, so we determined that this triangle, even though it kind of looked like it was going to be equilateral, it's scalene.